In the first part of section 8.4, we went over zeros and horizontal and vertical asymptotes. The last thing we need to talk about are holes in the graph. Now, holes in the graph are only going to happen in a rational function if you have the same factor in both the numerator and the denominator. Then there's a hole in the graph at the point where x equals b, unless x equals a b is a vertical asymptote. Okay, so again, you're only going to have holes if you have duplicate factors in the numerator and the denominator. So if there are duplicate ones in the numerator but not the denominator, you don't have to worry about holes. The only time you have to worry about holes is when you have them in the numerator and the denominator. So sometimes a factor will appear in the numerator and the denominator. When it does, one of three things can happen. And I'll just show you quickly down here. And you don't need to write this down yet. You can have a 1 for 1, so where they have the same number. You can have where they pair up and there's an extra one in the numerator. I'm sorry, this one was pair up and extra one in the denominator. This one's pair up, extra one in the numerator. And this one is where they pair up and there are no extra ones. So we need to talk about each case. So after you divide out all of the duplicate factors, and x minus k is still in the denominator, which is your first example down here. So let me move this down here. Here's your first example, still in the denominator. That means you're going to have a vertical asymptote. So we're just going to draw that we'll set that equal to 0, and so x equals 1. So basically you're reducing the fraction here, and this is going back to what we did before. If it's in the denominator, it's a vertical asymptote. Okay, the next one is after you divide out all duplicate factors and there are more x minus k factors in the numerator, so that's the second example we'll do, then the factors in the numerator result in 0. So remember that from the first part of section 8.4. However, if x minus k is going to be undefined because of the denominator. So you have a hole in the graph on the x-axis because it's in the numerator. And when it's in the numerator, the factor represents a 0. But when there's also one in the denominator, it's going to be a hole on the x-axis. So let's go down to the second example here. All right, so I have, basically I'm circling the identical factors, one in numerator, one in denominator. Only time you have to check for holes is when you have one identical one in the numerator and the denominator. But there's an extra one in the numerator. We learned from before that represents zeros. So you're going to have a hole on the x-axis, which means when you go to graph that, if we didn't have this, it would be a 0 or a x-intercept right at 1. But because it's undefined at 1, we're going to have an open circle, which is called a hole at that particular point. Okay, the last thing that can happen is there are equal numbers of x minus k factors in the numerator and the denominator. So after you divide out the common factors, there's no x minus k left. And since there's no x minus k in the denominator, there's not going to be a vertical asymptote. Since there's no x minus k in the numerator, there's not going to be a 0 at x equals k. So what's going to happen is there's just going to be a hole in the graph someplace other than on the x-axis. Now what graphs could look like, you could have a line that goes like this, undefined value here, and then it keeps on going. So the hole on the graph would look like that, and maybe I should probably write the graph in here so you can see that it's not on the x-axis. So it wouldn't be on the x-axis, it would be somewhere on the graph. So let's go look down at number 3. We have an identical factor in the numerator denominator and then no other identical factors anywhere. So we're still going to have a hole on the graph. It's not going to be on the x-axis because in order for it to be on the x-axis we would have to have identical factors and then an additional one in the numerator. Alright, so let's look at what that would look like. I'm just going to take this function and make sure that when you look at the factor, to find the exact location of the hole, you plug in x equals k into the reduced function. The reason why you plug it into the reduced function is that it's undefined at the original function. So you plug it into the reduced function and see the y value that you get. The ordered pair will be the location of the hole on the graph, but not on the x-axis. Okay, so that's what we have right here. We have we're using the value x equals 1, substituting into the reduced rational expression. And when we do that, this is going to be 1 plus 2, which is 3, 1 plus 3, which is 4. So our hole is going to be at 1 for the x value, x coordinate, x value of the coordinate, and 3/4 for the y value of the coordinate. So again, remember, the only time you're going to have holes is if you have identical factors in the numerator and the denominator. And then you have one of 3 cases that will happen. And you can kind of reason those out. If the extra one is in the denominator, it's going to be a vertical asymptote. Extra one is in the numerator, it's going to be on the x-axis, but it's going to be a hole. It's not going to be filled in. And if it's a 1 for 1, there's going to be a hole somewhere on the graph other than the x-axis.